Here we'll do one integral of the type that we have to use the table. So in this case, the formula to use is the sine formula, which says that, let me put this in medium because the fine is too thin, which says the integral of u prime sine of u dx is equals to, okay, the function whose derivative is the sine is minus cosine, so this should be minus cosine of u plus c. So here obviously we're going to take sine of u to be simply the sine of root x. Now what is u prime? The derivative of root x is 1 over 2 times root x. So the only thing we're missing is this 2. So we'll do our standard trick and put the sine of root x over root x dx. We need to put a 2, so we put the 2 here, which is in the denominator, and because it's in the denominator, should be a 2 multiplying outside, and now we have it. So here we have, this is 2 times minus cosine of root x, which is minus 2 times cosine of root x plus c. Don't forget plus c. This video will do integration by parts of the function log x divided by x to the third power. Remember, you have to divide this like u and dv. Here you have to differentiate to get the derivative of u, so it could be any function. Here you have to integrate to get v. So it's important that whatever we put here, we must know how to integrate. So we have a choice of the log of x cubed in the denominator. We don't know how to integrate the log, so we put it here, log x, and the derivative is 1 over x dx. I'll let me write the denominator like x to the minus 3 dx. So its integral is x to the minus 3 plus 1 divided by minus 3 plus 1, which is equals to x to the minus 2 divided by minus 2, or rather minus x to the minus 2 divided by 2. So the formula of integration by parts says that the integral of u dv is the same as uv minus the integral of v du. So let's replace all the terms here, and we have the integral of ln x divided by x to the third is equals to the product of u, which is ln x, times v, which is minus x to the minus 2 divided by 2, minus the integral of v, which is minus x to the minus 2 divided by 2, parenthesis, times the integral of the derivative of du, which is 1 over x dx. So that becomes, let's put the x to the minus 2 below as ln x divided by 2x squared, minus with minus becomes plus 1/2, we take it out, integral of x to the minus 2 1 over x dx. Now here this is simply x to the minus 2 times x to the minus 1, which is x to the minus 3, so we have minus ln x 2x squared plus 1/2 integral of x to the minus 3 dx, which is precisely, this is like dv before, so we know how to integrate. So that's equals to minus ln x divided by 2x squared plus 1/2 x to the minus 2 divided by minus 2. So let's put here a little bit of arithmetic, and becomes minus ln x divided by 2x squared, the minus in the denominator, here this minus becomes here, this minus here, 2 times 2 is 4, so 1 over 4x squared, and that's the same as multiplying by 2 the log and divided by 2, we have minus 2 ln x minus 1 divided by 4x squared plus c, don't forget. This part of the video is about the integral of rational functions, the quotient of two polynomials. Remember, what we have to do is split this factor or rather this fraction, x over x plus 2, x minus 1 as a number over x plus 2 plus another number over x minus 1. Doing the operation, this is a x minus 1 plus b x plus 2 divided by the common denominator x plus 2 x minus 1. So we have, this is a 2, doesn't look like, but it's a 2. So we have x should be equals to a x minus 1 plus b x plus 2. So let's give values to x. So we give the value of x equals to 1 because then this part will be 0. So 1 is equal to 0, b times 3. So from here we get b is equals to 1/3. Similarly, to make this equals to 0, we have x equals to minus 2. Minus 2 is equals to, as this part is 0, a times minus 2 minus 1, which is minus 3a. And from here we have a is equals to 2/3. So our integral of x over x plus 2, x minus 1, becomes the integral of a 2/3 x plus 2 plus the integral of b 1/3 x minus 1 dx, and this is equals to 2/3, and remember, log of absolute value of x plus 2 plus 1/3 log of absolute value of x minus 1 plus c. Don't forget plus c.